All right, everyone. I am here with Kavita Bala. Kavita is chair of the Department of Computer Science at Cornell University, as well as a research advisor at Facebook. Kavita, welcome to the TWiML AI podcast.
Thank you so much for having me.
I'm really looking forward to this talk. You recently gave a keynote at the Women in Computer Vision workshop about some of your work, and we will get deep into that in the course of our discussion. But let's please start out by having you share a little bit about your background and how you came to work in computer vision.
Yeah, absolutely. So I started off, so I'll just describe my academic background and more recent stuff that I've been doing. I got my bachelor's in the Indian Institute of Technology in Bombay. And then I came to MIT for my PhD, my master's and my PhD. And in fact, that started off in systems in computer science. And then I switched into computer graphics. And I got interested in computer graphics because I was very interested in sort of understanding images. And I like the visual aspect and the perceptual aspects of understanding images. So I started off in computer graphics. And then because of my interest in human perception, I actually started doing work more on the boundary of computer graphics and computer vision. And now my work sits sort of firmly in that, on the vision and the graphics side of boundary. So I do, on the graphics side, I've been very interested. I really do see them as sort of a yin and a yang. On the graphics side, we're very interested in building up models of the world, whether it's the shape or the materials or the lighting in the world, and producing images that look real. And the vision is the exact converse problem. You have these great real world images and you're trying to figure out what is the underlying model that created that image. So I've been very intrigued by both those sides of the question. And so that's where I sit with my research.
Got it. And do those sides, are they kind of independent streams of research, or do they inform one another and influence one another?
That's a great question. It's actually, for me, because of the human perception side of it, that there is a very strong tie between the two. But there's lots of researchers who sit squarely only on one side or the other side because they're looking at parts of the problem that don't overlap. But if you have this interest in perception, then I think that there's such a strong tie that you do end up seeing both sides of them.
And when you say perception, what is it about perception that ties them together strongly?
So on the graphics side, you're producing images, but for whom? There's a person who is going to be the consumer of that image, who's trying to then understand what you try to sort of stuff into the image so that they understand the world. For example, on the graphics research, one of the questions I ask is, what makes silk look like silk? And if you understand why silk looks like silk or velvet looks like velvet, you can then produce realistic images of silk and velvet, which is very important for textile modeling and of course, for the entertainment industry, etc. And that perception question, you flip it around on the vision side. When you have an image of cloth, recognizing whether it's silk or velvet is something a human being can do automatically, but a vision algorithm right now still struggles. So in fact, material recognition on both sides was one of the ways I got into research on both of these directions.
Awesome. So your research led you to found a startup that called Grocstyle that played in this area. Tell us a little bit about that experience and what you were doing there.
Thanks. Yeah, that's been a very, very fun and eye-opening experience. So I talked a bit about what I did. As I said, I did my bachelor's, my PhD, and then I came to Cornell, and I've been an academic at Cornell my whole life, so to speak, from 2002. And then I had, while we were doing this material recognition research that I talked to you about, where we're trying to take a picture and try to recognize all the materials in it. My student who was working with me at that time, Sean Bell, and I got very intrigued. We were looking at all of these images of great interiors of homes, because in our houses, we typically have a rich variety of materials and we wanted to recognize them. And if you want to design, for example, a robot, a house cleaning robot, it would need to recognize what materials it's seeing and play with it. So that's sort of what motivated our research when we're doing material recognition. And while we were doing that, we actually were browsing all of these great sites, these interior design sites of places where people would post great images of homes that they were building or that they had seen. And they would ask questions like, I wonder what that countertop looks like. It's marble. Is it really marble? What is it actually? And this led us to sort of realizing that there was a real hunger for the problem, which is called fine-grained visual recognition, which is not only recognizing that a table is a table or a chair is a chair, but going that extra step beyond and saying, this chair is the Eames chair, or that table is the IKEA, Mammoth table. And if you know that, and this is something that a random, consumer or a user who's looking at a picture, they know they like it, but they don't know what it is. And so it gives them an expert level knowledge that is available at their fingertips if you could solve that problem. So that got us, so Sean and I got really excited about that. And we wrote a paper at SIGGRAPH. This is in 2015, so it's been a while now. But in our first paper, we wrote about this visual recognition problem, how you could use deep learning for it with the right combination of data, the right learning architecture, and the right sort of all the magic pieces that go into making something that works end to end. We demonstrated that you can get really high quality fine-grained visual recognition. And that launched off our company.
Let's dig into those magic pieces a little bit. What are some of the key differences between the techniques that we would use to solve the coarse grain problem, which we do very well and are kind of, we can get standard off the shelf components that are fairly sophisticated, and this fine grain problem, which I think is still a bit more challenging, correct?
Yeah, it is quite a bit more challenging. And I can tell you, so, there are different pieces of it. One is we used a Siamese network. So you actually are training an embedding. So instead of actually just a classifier, you're training an entire embedding where, you can think of it as sort of, you need to know what your place in the world is. So it's like a global map, things that look similar cluster in the common part of an embedding, things that are dissimilar go to different parts of the embedding. So first is, this idea of using Siamese networks at that time was lots of deep learning ideas had been explored, decades ago, but people weren't using it quite in this context of using it for fine-grained recognition. And that was our first insight. Let's take that. But then the question was, how do you actually train it? You have some amount of data. So you get, these designer photographs, let's say, that say, here's a picture of this particular item. So it's this, a pendulum or, say a pendulum, let's say, or a pendulum sort of light. And you have the picture that you get from the catalog, which is this perfect image that comes from the manufacturer against a white background. It's all beautiful. Then there's some real world photographs. Somebody took it in their living room and they showed how they're using it in their space. Right. How to correlate these two is the hard problem. And you put this through the Siamese network, which says they're the same thing. Even though they look completely different, pixel for pixel, if you were to do comparisons between those two images, they look completely different, but they're the same thing. So you then train your embedding to pull similar things together and then push dissimilar things apart. And after 2 weeks of training, you arrive at an embedding that actually represents sort of the visual reality of that domain. So that was our first realization, is that you have to do that. But then again, some of the magic is actually you have to set up the right sort of normalizations, etc. So that we publish this all in our paper and we put it out there. But that helps in really creating a robust learning process rather than something that's pretty fragile.
Is the ability to go from the kind of in the wild picture taken on the cell phone camera to, something that's taken in a more sterile environment, is that a unique property of the Siamese network, or is it part of the training process, domain adaptation and data augmentation techniques and the like?
It's the Siamese network is basically saying that these utterly dissimilar looking things, pixel for pixel, are the same thing. So that's where it's set up with these loss functions that pull together the similar and push apart the dissimilar things. And in fact, so when we had first started this, we published this paper in 2015. I can tell you the whole story of the startup, but fast forward, Darknet, which was, I'll talk about Darknet, which was just released by Facebook, which is based on the Grocstyle work, essentially is the same idea at its core, except many, many more domains, a lot more data, and a few more tweaks to the error function. But at its core, that's sort of the high level idea. Once you get that, you can go actually very far with it.
And is this idea of the Siamese network architecture, is that are all networks where you're training, embedding space end to end? Are they all, the same? Is there something unique about the Siamese network that is different from other approaches to training and embedding?
Yeah, I mean, different people will use different types of losses, etc. But the core architecture there that was used is actually pretty robust and ends up being underlying a lot of solutions that people use.
Okay, cool.
But there are different kind of losses, etc. that people said. There's hundreds of papers and different alternatives. But the Darknet paper actually was pretty. So we created Grocstyle. The team went over to Facebook. So Facebook acquired. So I'll tell you a little bit about the story of Grocstyle. So Grocstyle, we launched it for fine grain recognition. Then we partnered with IKEA actually, and IKEA was very interested in adding visual recognition in their augmented reality app. So in augmented reality. Well, in furniture, you really want to visualize a piece of furniture in your house before you buy it. So AR makes a lot of sense in that context. But once you have, say you have an existing piece of furniture, finding out what it is, seeing what complements it, etc., are all good use cases. So they added our visual recognition into it. We were on the radar of Facebook. And then last year, Facebook acquired Grocstyle. And then this was in 2019. And then in 2020, in May, they announced Darknet, which is their core AI to make every image shoppable. It's based on Grocstyle. And actually, Sean Bell, who's my PhD student, was my PhD student, and is now at Facebook, is heading up the project. They have a KDD paper on what Darknet does. And as I said, it has much more data. It has every form of data. We had started off with furniture, but now it has furniture, fashion, automotive, automobiles, and other forms. It has 83 different loss functions, but sort of 3 of them are sort of these core, Siamese type losses that are there, and there are some variants on them. And once you add that in, you have something that actually is now powering commerce at sort of a Facebook scale.
Elaborate on this idea of 83 loss functions and how they come in. Are they all trained simultaneously, or are they trained in stages or phases or layers or something like that?
So they are trained. There's a lot of magic to that, and the KDD paper. No, but actually, it's just primarily 80 of them approximately are to get those various data sets in. And then about 3 of them are actually that the losses that pull things together and push them apart. So those are the ones that you use. And there was sort of this double margin. We had originally had a very simple function that pulls together and pushes apart to learn the embedding. Here, there's a slightly more sophisticated version that gives you a little more robustness to noise, et cetera, that gets added.
Got it. And so is it, can you think of it as kind of like an ensemble type of thing where a particular one of these loss functions will be, come into play when we're talking about sweaters versus tables versus something else?
Yeah, so it adds a lot of that various domains and various data sets that are coming in, and it helps you, incorporate them all into one thing.
Got it. And we'll be sharing in the show notes video. We'll be linking to the video of your CVPR keynote, and there's a very cool segment of that about 40 minutes in where you go through the demonstration of the system. It looks pretty cool in terms of, take a picture of or point the camera at a piece of furniture. It tells you in fine detail, like even down to the pillows, what those are. I guess I'm presuming that those are, well, maybe let me ask this as a question. Are you, in the case of that example where you're identifying a specific branded pillow, are you, would the way that this be used is you've got a base model and then you fine tune on a catalog or something like that? Or do you have to train deeply on the catalog? Is there a transfer learning type of element to this?
So the details of the KDD stuff are actually, I was not involved in some parts of that work, but the catalog, you keep adding as new parts come in. you incorporate them in with the existing embedding. So you're not going to go and just completely throw everything off, but there's a pretty stable, and then you add them in and you incorporate them.
And there was an interesting AR angle to that as well, where is there any ML AI component to that, or is that, traditional, you have this digital model of the piece of furniture and you're just placing it in space with AR kit or whatever you're using?
So in the original one, it was pretty separate. So the AR piece was completely separate, but it was doing its own thing. Longer term, right? Adding those digital models in for the training and robustness actually is an interesting thing too, which is something that we looked at in various forms too, and that's how we see one of the parts that actually where it'll keep as these models improve in quality, and they will help you with sort of the long tail of distribution of products that you might not actually otherwise be able to recognize. But
so are you saying there that are you alluding to training on a 3D digital model as opposed to a 2D image and using that to inform the model itself?
We found that actually having both of those helps with robustness. Now, that's not what the Facebook thing is doing. The solution is doing. In fact, that's what we did in Grocstyle, where we actually have played with having both together, and it does result in much more robustness, to various angle variations, etc., and a lot more variety that you can add in. And so that was certainly something we had explored in Grocstyle.
And did you flatten the 3D images to a 2D projection so that they can be useful to a CNN or something?
We fed them in a pretty traditional way, but it was more that we explored a richer variety by using the 3D model. Yeah.
Interesting.
So yes, there's been interesting work also on looking at sort of the 3D CNNs itself, right? Which is a whole different game. And actually, as we get, one of the applications of this technology is definitely within an AR mixed reality kind of a context. So going forward, I think all of these are going to get quite a bit more sophisticated in terms of incorporating virtual 3D data. Right now, the material models, etc., tend to be a little limited, but they could go far.
And when you talked about the Darknet being released recently, what is that release? Is that a data set? Is that a paper? Is that a service? Is that a model that you can download? Do you have the details there?
Yeah, so Darknet has been deployed, I believe, within the commerce side of Facebook so that it is used for captioning, automatic captioning. So when a person uploads an image, then it automatically provides captions, it does recognition, etc. So they see this as sort of the core engine that they're going to use to continue to train up to do, as they say, make every image shoppable, which means right now it's for some set of domains, but the hope is to make every aspect and every domain to be completely recognized.
And I imagine that you are a biased believer in this vision, but lots of folks have been going after this for a long time, not just, Pinterest and the like, but also, we've talked about this in the context of that, that old technology TV, right? Where the TV providers would be able to, on demand or pull out products and offer them, and has never quite materialized. Is there something, what's your take on the space in general?
I'm definitely a believer, right? I believe that, yes. So I do believe, and in fact, I'll talk about sort of, I've actually moved on to the next sort of how you, assuming this stuff works, what do you do with it? But I am a true believer in this for sure. Video and recognition at scale, as you're walking around, having every part of your image being fully annotated with a fully recognized understanding of not only at the highest scale, at the most detailed scale, what am I seeing? Is this particular detail, but also meta information, the history of the item. All of these I see as being something that will be available to you as you walk around with your AR sort of mixed reality glasses or something else. And there's a very interesting movie, I don't know if you've seen it, called Anon, which was available on Netflix. It's actually quite a dystopian world, but it's talking about something called the mind's eye, which is sort of this retinal implant. And as you walk around, there's a full overlay of everything you see, has an overlay of information with it, so that you can explore. You basically are plugged into this full knowledge, comprehensive knowledge of the world you're in. I think that's actually a very exciting interface that I hope we will be able to realize. And that means that every image, every video, everything in person you see will be recognizable and tagged with information. Now, there's all kinds of security implications of such a thing, of course, and privacy implication. And of course, society has to look into those. They're very important to get right. So I see that as also going hand in hand with the kind of development of this kind of technology. But what's interesting is how much it could potentially enrich your life if you have all of that information available on your fingertips as you're walking around in the world, right? If you walk across a tree or a flower, it immediately recognizes it for you. It just enriches your life to know all of the things that you're potentially interacting with.
What's your personal take or read on the societal implications, and how do you balance those, or kind of answer for yourself the question of, on the balance, should this be something that exists? I was just reading an article about, I guess the Slate published an article about Customs and Border Patrol has access to some database of scanned license plates, and apparently they're crowdsourcing them. They give people, some company gives people these license plate scanners, and they just, random people driving around with these scanners. And, as you've alluded to, we're moving to this world where everything's recorded on some camera and uploaded to some cloud. How do you parse whether that is what creates the dystopia that was alluded to in your movie, or, whether there are other factors?
I think it's a fundamental question, and it is critical for us as a society to grapple with it. So I think it is one of the most important questions we need to deal with. And actually, different societies and different cultures are arriving at different places as to whether they believe they should respect that privacy of an individual or not. Right. The EU has a very different set of laws. The US has a different set of laws, and different parts, different countries, China, for example, have very different set of laws. I believe that from a technological point of view, I think we should develop the technologies and also keep privacy preserving aspects of it as fundamental to how we develop these technologies. So we should think about privacy preserving privacy preserving machine learning, when you can learn large scale, useful, because the recognition that you get through, the algorithms you learn are actually incredibly useful, right? They have made society more productive. There's lots of positive benefits, but there is clearly the negative side to it too. So while you design your technologies, you keep an eye on this aspect that you might want to preserve privacy in it. And separately, I think you actually have to have that societal and policy engagement, where there are clear policies about what, and clear teeth with the policies that come with it, as to what the society wants to sustain, what aspects of privacy it wants to maintain, and how we should go make sure that that's executed on in all of the technology companies that releases. So I think this is a critical question, and we should definitely do it. I'm not of the position that, though, because that there is a danger of it can be used badly, that you should not invest in this technology at all and pull back. That's not reasonable. What the right thing to do is to design the mechanisms to protect the values that we hold dear, and privacy is one of them, and make sure that they can be executed upon. And this requires, innovation, not only in the algorithms, also sometimes hardware, right? Your trusted computer base, and what, how you preserve privacy there. So all the way is what you need to maintain. And I think that's how we should approach this investment.
Is the current, how far have we gotten in terms of integrating the work that's happening around privacy preserving machine learning and embeddings in general, and or the specific work? Are they kind of orthogonal concerns, or does the Siamese net, for example, have to be aware of differential privacy or some kind of privacy preserving technique in order for it all to work?
Yeah, so I think, so the kinds of work that we've done in the case of recognition, where you're applying it for, products and stuff, there's not so much of a problem, it's actually okay. But yes, when you get to face recognition, recognition, for example, that's the kind of dangerous technology where you have to be very careful in how you, and there's also health data and things like that, right? When you have that embedded in, you have to be very careful in designing it from the get-go to actually have that kind of privacy preservation in it. So I think that's how far has it gotten. I think it's a very, very open, ongoing area of research that people are continuing to explore and push on, and hopefully we get to useful places. But I think it's wide open.
Okay. So your work on Grocstyle kind of set the stage for you to start to explore some kind of broader cultural implications of this kind of approach. Tell us a little bit about those.
Yeah, so I got very interested, when you're looking at this problem of how do you make an image fully understandable. So fully shoppable was the first one I said, but let's assume we have that technology. So fast forward 10 years, we do all the innovations, and we have a way so that every image that we have available to us is fully understandable. What can I do with that knowledge? And think of it as, let's say there's sort of 100 years from now, somebody's going through our historical images, trying to understand who we are. So there's an anthropologist who's looking back in time and trying to understand who we are. It turns out that we are recording ourselves at an unprecedented rate, right? We're storing, whether it's on Instagram or on Facebook or, any of your technologies, we are recording ourselves and posting information about ourselves online, which it turns out is this giant camera of the entire planet. And so when you have a planet-sized camera, what can you understand about the planet? So I'm working with cultural anthropologists, and this is a joint work with Noah Snavely, Kevin Madsen, Utkarsh Mall, and Bharat Hariharan. These are all my Cornell collaborators who are looking at these questions of take all of the images from social media and can we understand people? Can we understand what do people wear? What do they eat? Who do they hang out with? Or, what kind of social groups do they hang out with? Do they hang out in pairs, in big groups? What do they do? What kinds of activities they do? And how do people do these things differently in different parts of the world? So this is where the cultural anthropologists are very interested. So normally how a cultural anthropologist would work is they would go and they would visit a site. So they would visit a different country. They would go and embed themselves there for a few months. They do interviews, with a handful of people, and they try to say, yeah, this in this place, they are very, these are the kinds of clothes they wear. This is kind of what they eat. These are kind of the social norms. And instead, we have this world-sized camera that can give you all that information, the visual information that you can find. So that's what motivated this sort of work that I've been doing. One, we have two projects. One is called Street Style and the other is called Geostyle. And we started looking at the first problem. What do people wear around the world? So how do they dress similarly or differently around the world? And this has ended up being an incredibly rich sort of exploration of the human race. And by the way, when we're talking about, you have to be very careful talking about the privacy issue. As I had said before, you can actually do this in a privacy preserving way. You can block out the faces. It's not about the faces. You're actually just trying to understand what people wear in different parts of the world. But you do want to be careful when you're asking these questions. What is everybody doing at every day? It's not Big Brother. It's more understanding actually population distribution. So it's understanding how we work as a group, not about violating any individual's privacy. So, okay, so what do we do? So the first thing we did is let's look at how people dress across the world. And so we recognize, we apply a standard sort of detect the body, recognize what a person is wearing, what's the top, what's the bottom, are they wearing glasses or not, etc. So there was some very simple set of attributes. But then what we did is, just like that embedding, I told you, we learned this embedding where we clustered parts of the picture, parts of the dresses that looked similar into the same region of the embedding, and then the different clothing got clustered, separated out in different parts of the embedding if they look different. Once you have this embedding, now you get this really interesting thing. So you can go and do unsupervised learning, and you can find these style clusters. And each style cluster stands for some very unique thing, like people wearing a plaid shirt and say, and glasses. That's one particular style, let's say. Another style is a dark jacket and say a white shirt. And when you look at these style clusters, because we've collected this information from the whole world, we had actually started with sort of 3 years of Instagram data from 2013 to 2016. And because we've collected around the whole world, you can then look at a particular style cluster and then go and look at, well, which cities did those images come from, and which times of the year did they wear those clothes. And you find really fascinating stuff. So there are some very unique clusters. For example, we had one cluster that had, and I'll share the slides with you, but this very unique headgear. And it turns out when you go and you look at which cities it comes from, there's one city that lights up. It's Lagos. And this is the galet headgear that women wear there. And it just pops right out. So, we found very distinctive things that people wear in different parts of the world by looking at these style clusters. We also found one very distinctive cluster that was not actually spatially unique. So it was, when you look at the cluster, it's pretty obvious. It's people wearing sort of these heavy dark jackets with sort of shirts underneath, a layered shirt underneath. And it turns out when you look at, which cities they come from and which time of the year come, sort of x-axis has the city and the y-axis has the time, you can actually see all cities have this, but it's winter that it pops up. So, and you also see the Northern Hemisphere pops up in December and January. And conversely, in the Southern Hemisphere cities, it pops up exactly 6 months later. So essentially, just by looking at these clusters, you then go and look at where the data is coming from, and you understand how those people live at that time. Or if you were to go and visit that place, you should go and look at this cluster and say, oh, I'm going there in January. I think this is the kind of clothing I need to take so that I can blend with everybody who's there. Those are sort of the distinctive clusters. On the flip side, there are these very standard clusters. It turns out there are some things that the whole planet wears. Like there's no one city that's very unique, no time of the year, and that is plaids. Plaid shirts are popular in the whole planet. Also blue shirts, button-down blue shirts. Like people wear that, it's their standard go-to kind of slightly formal wear that they wear when they're going out and taking selfies of themselves. So that was very interesting. So that was our original street style work. And so that actually led us to sort of this geo-style work where we said, this is interesting. Can we automate sort of discovering very unique clothing across the world? And so we created a whole mechanism where you can find spikes in these clusters when people really dress in something. And it was fascinating. So we now found out things like sporting events, protests. So if everybody dresses a particular way in a protest, then there's a big spike in those clothes. So for example, in Spain, there was these protests in 2013 or 2014 for Catalan. And so they all dressed in these yellow shirts on that one day. And when we were doing the recognition, there was a big spike in the yellow shirt wearing, and we could go and say, there's something interesting going on there. It's a political rally, and you can just find that. So we learned about a social event that we didn't know about just by mining the sort of visual data.
And so in order to do this, were you able to use the embeddings that you created for Grocstyle, Darknet kind of out of the box, or do you have to customize the loss function or the training data or some aspect of the system?
Training data, yes, not the loss function. This one is actually, we use this is a Grocstyle. So this work also started in 2016. So it was more in that era. Darknet is very recent. We just use the standard recognition box to learn this embedding with a very simple amount of training data. We had, I think, 27,000 labels to recognize different attributes of clothing. Now, this was very focused on clothing. If you had to recognize food or recognize activity, we'd have to apply a slightly different training. But we did a simple thing of recognizing some attributes. And then what was interesting was this unsupervised sort of recognition of the style clusters. That's where it became interesting. After you learn the embedding, then discovering these style clusters is where they sort of get this rich discovery process, which is fun.
Mm-hmm. You talk about this as being, part of an era where every image is understandable, and this kind of the word understanding has a lot of connotations. I think in this case, we're talking about humans using this as a tool to increase their understanding of the cultures. Does this play into computers being able to better understand the images as well?
Oh yeah, so that would be so computers. So I was taking as granted that the computers can do the recognition piece, right? If they do a job and they recognize it, that's great. But the deeper question of actually understanding cultural trends and understanding sort of socioeconomic, social events or events of great political import, understanding that just by looking at the data is something that you would hope an algorithm could do. And we are a long way off from that. But this takes the first step, says, can we actually recognize these events that are very unique? And then actually, and in fact, there's a question. So you recognize a visual event, everybody's wearing a yellow shirt, but it's just a yellow shirt. But yeah, one of the things we found also, one of our style clusters was there was a big spike somewhere in around in the middle of this time period, and we were looking at it. It was of a yellow shirt with V-neck and graphics on it, and it turns out we had discovered World Cup soccer. So everybody was wearing the World Cup soccer, the insignia and all of that, and we just recognized that in a style cluster. So you can find these clusters, but then if you correlate them with captions and other stuff that's going on, you start to see culture. You can recognize something as a cultural event versus a sporting event. So that's where it starts becoming interesting, where you can have the algorithm hopefully recognize new, cultural events.
Mm-hmm. Great. And so where do you see this going? What's next in, the next step or two in this line of research for you?
I'm super excited about this kind of, temporal recognition. And I think this is it's a huge opportunity because of the amount of visual data we have. So one of the big next steps we're looking at is taking this and applying it in the context of satellite imagery. So again, can we look at large scale trends around the planet where something interesting spikes up that's local, something that's cyclical, right? That changes season by season versus something that's a one-off. And that's sort of what we discover in Geostyle. If we discover the one-off events, are they problematic or are they a good outcome? So those
here we're talking about examples like forest fires or landslides or crop growth or things like that.
Yeah, so those are, we looked at, and there was a, algal bloom. All of those things are things that you can actually study. There's incredible satellite image data. Can you then, there are things that are done cyclically, as I said, just seasonal. And then there are things that are the man-made. And that's exactly what we're trying to analyze. And we're working in this case with crop scientists. And they're very interested. This makes a huge difference. If you can make simple predictions of how, just seeing sort of some early signals, you can predict how they change over time, for example, which our event, mechanism can do, because it basically tries to fit sort of the temporal signal of the pattern it's seeing. Then you can make a huge difference in, predicting whether or not you'll have a productive crop, whether you should take some steps to mitigate problems that you're seeing early on. So those are the kinds of problems we're looking at.
Awesome. So satellite images, any other future directions for this?
That's one of the big ones that I'm very excited about, but we continue even in the context of, as I said, Instagram is one example, but all of the social, the rich variety of social media, looking at what people wear is one piece, but there's so much more, our activities. And as I said, how do we congregate? How do we, are we just loners who are taking selfies against monuments, or are there actually groups of us? And so there's a lot more to do on understanding sort of social interaction in this context too, which is, so it's two different, satellite images versus human data sort of, but there are two very interesting and distinct paths to take, which I'm excited about.
Awesome. Awesome. Well, Kavita, thanks so much for taking the time to share with us what you've been up to.
Thank you so much.
Cool stuff.